Yeah, they can do their own.
Good
But it'll
afternoon.
be similar to those. Yeah.
Oh, good afternoon, class. I'm Mr. Precella, and today we're going to start this course with the first assignment, square roots. And we're pulling it up.
There's two ways you can get to it. One way is, oh gosh, it's the first day of the semester. You can open it, click assignments, open. Oh,
And
we've already clicked on the 3 videos. It got small again.
because he went behind us.
And now we're going to start here with question number 1.
But I need to talk some first.
Oh, okay.
I'm going to switch it over. And here we go. Okay. As a student, I remember I would just be like, oh, please don't let the teacher start teaching today. And then once I became a teacher, oh, I know that, you know, as a student, I always thought if I were the teacher, I wouldn't start teaching on the first day. But then once I became a teacher,
Tim, when I was
what?
a student, I was always, oh, I hope this isn't a teacher that rambles on and on before he starts teaching. Okay, get going.
Okay, here we go. This symbol that I'm drawing is called the principal or positive square root.
Or just square root.
Or just square root. And to illustrate that square root of 25, we say that the square root of 25 is 5 because if you take 5 and square it, that gives you the number under the square root symbol. I'll refer to this symbol as a square root symbol. Another word for it is a radical symbol. But the square root of a number is the number that can be squared to give you back the number that's underneath the radical. As I said, this is called a radical symbol. And the thing under the radical is called the radicand.
But it's frequently just called the thing under the radical.
Yeah, but
or under
frequently I
the
just call it, most of the time I just say the thing under the radical. But formally the thing under the radical is called the radicand. Let's look at number 1. Let me write that problem down. Number 1, we want the square root. We want the square root of 64. Oops. Switch over. Okay. Now realize each person's numbers are different. I have a square root of 64 as my number 1. You may have the square root of 49 or the square root of 25 or something. But everyone's number is different. And when you're taking tests, that's the same thing. Everyone's test problem is different. So
copying is virtually
useless. Yes, okay. So what number can you square to give yourself 64?
8.
8. Okay, I agree. So we go and go back to my lab. We click in the box, and when you click there,
it'll then show all these little tools, which you don't need right now. You just type in an 8 and say check answer.
For an answer a problem where you have to type in the answer yourself, not multiple choice, but you type in the answer, you have 3 chances to type the correct answer when you're doing homework, okay? If I typed in the wrong answer, they would have said, oh, you messed up, you want to try again. So we say numbers, switch back to my page. Numbers like 64 and 25 are said to be perfect squares because their square roots are positive integers. And let's write out a list of some perfect squares. 1 squared. 1 times 1 is, well, 1. So I'm not even going to bother writing. I guess I'll write it down. 2 squared is 4. 3 times 3. 3 squared is 9. 4 squared is 16. What's the next perfect square? 25. 5 squared. And after that, 36. 6 times 6. And
49.
7 times 7 is 49. After 49,
64.
okay, 8 squared is 64. 9 squared is,
81.
okay, 10 squared is 100. 11 squared is
121.
121. 12 squared is
144.
144. I agree. 13 squared
I'll start
is
helping out. 13 times 13, 169.
14 squared is
14 times 14, 196.
5 squared
No,
is, I mean,
15.
15 times 15 is 225.
Where does this end, Tim?
16 times 16 is 256. And that's a good question. Where does
Dot,
this
dot,
end?
dot.
It never
doesn't.
does. I bet you this is far enough for us, okay? I doubt we'll run into any perfect squares bigger than 256. Now, we say, well, suppose we wanted to simplify the square root of, let's see, the square root of 50. That's what I was going to say.
Is 50 a perfect square?
No, 50 is not a perfect square. If a number is not a perfect square, you can probably still reduce the square root, though. What you do is you ask yourself, what's the biggest perfect square up here that divides evenly into 50?
49.
Okay, well, 49.
Oh.
Now, divides evenly
divides
means
equally
that the
25.
remainder is
20.
0.
Did y'all hear that? 25 times what would give you
Sorry.
50? 2?
25.
So
The biggest number that divides evenly into 50, well, it has to be a number smaller than 50. 49, now you'd have a remainder of 1. 36, you'd have a remainder of 14. It's 25. So here's how we're going to think of that. We're going to think of it as the square root of 25 times the square root of 2. 25 times 2 gives us that 50. Now, what's the square root of 25?
5.
So we can reduce this to 5 times the square root of 2.
that's
And
what,
you can read this in multiple ways. You can say 5 times the square root of 2. You can say the old-fashioned terminology, when I was learning algebra, we said 5 on the square root of 2. No one says that anymore. Most people just say 5 square roots of 2. But the number that's left under the square root can't have any perfect square divisor. The only number that'll divide evenly into 2 is what number? 1. Okay. The only divisor that this number, perfect square divisor that this number can have, is a 1. That means you know you're through reducing it. So we go back.
I wanted to show something. On most calculators, like on this one, if I go second square root of 50,
That's not going to give you an integer.
most of them give this. There's a few Casios that I know of that, not all Casios, but a few of them, when you punch in square root of 50,
It gives you 5 square roots of 2. And I think the Casio FX250, something like that, is under, I'm pretty sure it's under $25. Back when I was in school, back in the 80s, a calculator that did that, it was just unheard of.
science fiction.
Yeah,
But let's
science
go on to
fiction.
problem number 2
No,
now.
you got to type, oh, okay.
No,
You're right,
that's-
that's the,
Okay. Is that, oh,
Look at
wow.
that.
Is this a perfect square? Hey, let's get it wrong.
Okay, get it wrong.
What's the answer to this? A square root of 100?
10.
10? Well, I want to demonstrate what you do if you get a problem wrong. I'm going to put a 2. We know the answer is 10, but I put a 2 and that's wrong. And so they say, okay, that's wrong. I can still do it again. It says check answer. So let me change that 2 to 21. Check answer. Still wrong. It's getting annoyed at me.
Final check. This is the last chance you have of entering the correct answer. If you don't get that answer correct,
Look at what happens. It tells you the right answer, and you can either move on
which is not recommended.
Or do a similar question. That's what you do, a similar question.
If you don't repeat it and get it correct, you're going to have that number 2 wrong, which means you're not going to be able to make 100 on this assignment. So you should be able to make 100 on every assignment. What about the square root of 225? Here's a similar question.
Uh-huh.
What's the square root of 225?
14.
I don't think it's 14. I think it's 15.
15.
15?
Is
Check
it-
15 times 15. Or if you have a calculator, use your square root key to check the square root of 225. It should give you the integer 15.
So you've got to make it 80 to move on, so you can't just be skipping or not doing these problems. Okay? And there's got to be some sort of a catch. Oh, wow, I can do this at home, or I don't have to come to class
And
if I don't
notice-
want. But you got to do the stuff. You can't just jump around.
Notice that there's an X up here for number 2. You've gotten it wrong, but now that you've got it correct, notice you get that green check. So you're going to get credit for it, okay? Hold on a second.
Number 5. Okay, so we've already did number 4. I think we missed it on the recording.
Yeah, the square root of 18, we said it was the square root of 9 times the square root of 2. The square root of 9 is 3. The square root of 2, well, that just stayed under the radical. Now, what's number 5? Oh, I'm glad
A
you
lot of words. Okay,
simplify the square root. Okay, this is the
Notice
square
this
root.
one's different. It has that option B where it can't be simplified. Oh, I wonder what that's all about.
The square root of 53.
Is 53 one of our perfect squares?
No.
No? Okay, so it has to be less than 53. What's the biggest number up here that divides evenly into 53?
7. None.
Well, let's check. Try to pull up my calculator. I heard 9 and I heard 7.
No, I said none.
Oh, 53
none.
divided.
Oh, you said none.
no-
Okay.
oh,
None.
Where is
None,
it? But here's
sorry.
my thought. 53 divided by 49.
No, there's a decimal.
53 divided by
36.
36. This is just trying to show what my thought process is. 53 divided by 25, and so forth. The only one that doesn't give a remainder or a decimal number is if you divide it by 1, which isn't going to do anything.
53 divided by 1 would stay a 53 underneath there. So the square root of 53 cannot be reduced any further. That's just the square root of 53. 53 is a prime number. The square root of any prime number is going to be cannot be reduced. So let's see. Oh, it's already simplified.
Oh, no, wait, here. They say it's already simplified.
Already
Okay.
simplified. Any questions on our logic there? If there's no perfect square that divides evenly into it other than 1, then it can't be reduced any further.
I remember years ago a student telling me, wait a minute. My teacher in high school would give us 100 problems and you only giving us 15 or 20. I need a lot more. And I was like, you can have as many as you want. Let's suppose you need another problem like number 5. X this out. Don't go to the next one. Just close it out and look what the little tab says. Similar question. So yeah, let's do another one like this. Is 43 going to be one of those can't be simplified? Is there any perfect square that divides evenly into 43?
43 is a prime number.
Yeah.
The square root of 43 can be reduced.
There.
The square root of 43
Oh,
already simplified.
but you can redo it as many times as you want just by clicking similar problem.
Number 6.
Okay. Oh, this is a good one. Don't decide, oh, it's going to be can't be simplified because they gave that option. Nope.
The
Square
square
root of
root of 24. First question, is 24 a perfect square?
No.
No. What's the biggest number up here that divides evenly into 24?
4.
4, I agree. You can think of it as the square root of 4 times the square root of 6. 4 times 6 is
And
24.
now he's about to write a blue what number?
4.
No, the
No,
square root of
two.
4
Two.
reduces to
Right,
2.
But you're saying the
Yeah.
colors here do mean something. Like this green square root of 25 became a green 5. The green square root of 9 became a green 3. The green square root of 4, the blue square root of 4 became a
But they
blue
don't
2.
always. Sometimes I just change colors just to.
Here they mean something. 2 square root 6. Okay. I think through 12 are just these type of
Number
problems.
7.
Oh, square root of 18. Boy, that sounds familiar. Have we already done square root of 18?
Yes.
Well,
It's
Remember the square root of 18? We said the square root of 18. We said that 9 divides evenly into it. So that's the square root of 9 times the square root of 2.
this doesn't happen very often.
Yeah, well, it's exactly
The
the same
same
that
problem.
we've already done. And then the square root of 9 we replaced with the 3. Do y'all remember that problem? Even though you've already done it, you still got to type the answer in again, or else you're not going to get credit for number 7.
So 3 square root of 2. Oh, we're just chugging on along. Got 20 problems to do. Oh,
Number 8,
square root of 360.
the square root of 360. Well, I'll tell you right now, 360 is not a perfect square. We didn't go that far on our list of perfect squares, but if you punch in the square root of 360 in your calculator, you're going to get a decimal number. You're not going to get an integer. So
I wonder, does anyone have one of those little calculators where if you punch in the square root of 360, you'll get it'll actually do it the way we want it with the square roots?
is anyone looking at the answer? Is your calculator saying 6 square roots of 10? If your calculator, when you punch in the square root of 360, says 6 square roots of 10, then you're one of the lucky people that have one of those little calculators that simplify the square roots in terms of square roots for you. Anyone, their calculator saying that? No? Okay, well, that's fine. I'll tell you right now, 360 is not a perfect square. What's the biggest perfect square that divides evenly into 360?
36.
36. 36 divides evenly into it. Nothing else bigger than 36 goes in. So if we have anyone that's, unfortunately, it looks like the red ink is the thing that shows the best here. So next to that black ink. So if you have trouble reading, focusing on red colors, then you tell me and I won't use them. Or any particular color. But I'm going to think of that as 36, the square root of 36 times the square root of 10.
In place of the red 36, he's going to put the square root of 36. He's going to put a red
6. And what will I do with this thing? I'll just write it down. So 6 square roots of 10 for our final answer. Any questions on our logic there?
Make sure you're using the biggest number.
The biggest perfect square that divides in even.
9 divides evenly into it. That ain't going to get 9 times 40, but that ain't going to give you the right answer because 40 can be reduced further.
4 divides evenly into it. You have to use the largest perfect square.
And what did y'all say that is?
6 square roots of 10. I wonder if we had used 4. Well, I mean, 9.
It's not that smart. It's going to say wrong.
It is? Okay. Yeah. It's not going to say you need to use a bigger number.
I don't think so. Oh, wait. 20 square root of 28.
Let me write this down.
Number 9.
The square root of 28. Okay, switch over. Okay. Is 28 a perfect square? No. What's the biggest perfect square that divides evenly into 28?
number was 28.
28.
Uh-huh. Oh, square root of 28.
4.
Uh-huh.
4 times. I think 4 is the biggest perfect square that divides
think it's
evenly
the
into
only
20. Other than 1,
one.
I think 4 is the only one that divides evenly. I heard someone say 16. No, 16. If you divide 28 by 16, you're going to have one remainder 12. So you'd have a remainder. No, you'll have to use. So you're thinking of it as the square root of 4 times the square root of 7. Any questions on our logic? This is the key part right here. You have to figure out what's the biggest perfect square that divides evenly into that number 28. You said 4. What am I going to replace this red square root of 4 with?
2.
Just a 2. What am I going to do with the square root of 7? Just move it on over there. Nothing. For 2 square roots of 7. And once again, the number that's under the radical can't be divisible by any of these numbers other than 1.
What question?
If there's a perfect square that divides evenly under that radical, then you're not through reducing the thing. Question.
Oh, okay, yeah, that was my question. Was if you could like reduce down further?
You
for the
could keep
second
going,
But
but
not for this. And
but
if
not
you
for this
did, then that means you didn't choose the biggest.
perfect
Okay,
square.
so
If
you
you
use
use the
the biggest
biggest
number.
perfect square, then the number under there has to be something that you can't reduce any further.
Yeah, that was my
Okay,
question.
that was a good question.
Did I type in the answer there? No, I did not. 2 square root of 7.
Okay. Okay, let's stop. Notice down here, there are some help buttons. This thing here, view an example. It's an example just like the thing we're doing, okay? I mean, you know, in a regular printed textbook, each section may have what? 5 examples. And I remember as a student, I'm stuck trying to do a problem and there's no example that looks like it. The view an example is just like the problem you're
It might
trying
be
to
done
do.
a little, they might present it slightly different from how you write it,
But
it's still the same thing.
also, the help me solve it. Help me solve it. It'll step you through the problem. But when you do that,
it will immediately change your numbers and you'll have to do a whole different problem. Okay?
so I'm not going to click on help me solve it, but
Because some of you may have already written down the 208.
this is number 10, and we want the square root of 208. Okay. 208. Let's look back at our list of perfect squares.
And I'm going to pull up my calculator to help us
Is
out.
208 a perfect square?
No.
No. Well, it has to be the answer. The number that divides evenly into 208 has to be smaller than 196. I know that, but which one of these numbers
16.
will divide evenly into 208? I heard someone say 64. Let's check.
Well, I'm going through. Here's my thoughts.
What is that?
Ooh, clear. I meant to do a divide. 208. Here's just, I'm thinking. 208 divided by 100. No.
No.
That looks like a 2.00, but it's 2.08. So no. What about 81? Does 81 divide into it? No. 64? No. 49? No. If I get all the way through and don't find one, then you choose the already simplified. 36? No. Wow. Definitely not 25. 16? Oh,
There it is.
16 times 13.
So
Okay.
switch back.
Switch
That means
back
we have
over.
this to my page. Oh, here. The square root of 16 times the square root of 13. And what am I going to write in place of the square root of 16?
4.
So I'll have 4 times the square root of 13 as my final answer. Any questions on our logic there? You're asking yourself, what is the biggest perfect square that divides evenly into that number under the radical? And in this case, for us, it was 16. And how do you determine that? Well, I'd have a calculator with me to help with the number crunching.
Well, that's what
That's
we did
were
right
doing.
here.
That's what I'm saying. So type in the answer, 4 square roots of 13.
4 square root of 13. And we have one more like this.
Number.
Oh, you know what? Don't write that down. We've already done that.
If you select help me solve it, that changes the problem. So don't write that down.
Okay, and that's going to wire. Okay. There. Oh, wait. Well, have we already done that?
I don't think so.
Oh, okay.
No, we didn't do D3.
Okay, the square root of 54.
54. Remember years ago, a student telling me, whenever they got really big numbers, they just help me solve it until they got one with small numbers. And I was like, well, can't do that on a test.
Yeah, that's right. On the test, you're just stuck with that problem. Okay, let's look back at
Our list of perfect squares.
Here's my list of perfect squares. We're looking at 54. It's got to be something smaller than 54. So from 49 down to 1. What's the largest number there that divides evenly into 54?
Theoretically, the number is, it's got to be smaller than half of 54. You could have just started with 25, you know. 27 divided.
Mm-hmm. What's
Okay.
the largest number that divides perfect square that divides evenly into 54? Y'all should be able to guess this one.
So far, we're down to 9.
Any ideas?
Oh, it is
9. 9
Yeah,
goes
9
even.
times 6.
9 times 6 is 54. So we're thinking that's the square root of 9 times the square root of 6. And what am I going to write in place of this square root of 9? 3. What am I going to do with this stuff? Just move it over there and write it down for 3 square roots of 6. Any questions there? The largest perfect square that divides evenly into 54 is 9. The square root of 9 is 3. 9 times 6 gave you 54. That's where that 6 came from. And it has to stay under the radical. Look over here. Look at the perfect squares. We have a 6. There shouldn't be any number here that divides evenly into 6 other than 1. And sure enough, that's it.
And dividing evenly, you mean with remainder of 0.
Any questions there?
Let me go ahead and type it in. 3 square root of 6.
I'll tell you, you'll know when you're old, when you're on vacation and you're like, about 2 weeks into it, you're like, yeah, I'm ready to go back to work. It's good to be back at work.
There's so many people asking, why haven't y'all retired? You know, well, first of all, I don't feel like I'm old enough to retire. 60, you know. But I don't know what the heck I'd do if I did. That's another way you know you're old. If you're like, oh, I'm not going to, you know, what would I do if I were retired?
I went everywhere I wanted to when I was in my 30s, 20s and 30s. I've gone everywhere I wanted to go.
Don't have any desire. Well, I'll go ahead and show number 12, but you're going to have to do a little
do
talking.
some writing, talking.
The square root of 2 times the square root of 10. I'm curious. What do y'all, if you were just going to guess at how to do this, what do y'all think we do to the 2 and 10? Any ideas? How do you think we would? It says multiply.
You know something? Look at this.
Oh.
Okay, switch over here. Okay. Look at how I wrote. I said the square root of 54. That's the square root of 9 times the square root of 6. So we're just going to go backwards. Here, 54 is 9 times 6. Well, 2 times 10 is what?
20.
So we have the square root of 20. What's the largest perfect square? Is 20 a perfect square, first of all? That's what I should ask you first. Is 20 a perfect square? No. What's the largest number that divides evenly into 20?
10.
The 4. So you'll say that's the square root of 4 times what? 5. And then the square root of 4, that's where you write it as 2 square roots of 5. Now, to multiply square roots, you first of all have to make sure that they're square roots. We're going to see other types of radicals in this course. We're going to see cube roots. What number can you cube to give you the number under the radical? But eventually we'll be seeing some cube roots. You can't multiply a square root by a cube root like this. It has to be a square root times a square root. But to multiply square roots, multiply the stuff that's under the radical, and then simplify the square root. I think I'm going to say multiply the radicands rather than the stuff under the radical, but that's what a radicand is. It's just the stuff that's under the radical. I'll say multiply the radicands. Multiply the radicands, and then simplify.
Like we did on problems 3 through 11.
We multiplied the radicands, then we simplified the way we did on problems 3 through 11. Any questions there on our logic? What about number 13?
Now I got to punch in, I forgot to put that 2 square root of 5. Right, I should remember that. Mm-hmm. Oh,
I like this. The square root of 19 times the square root of 19.
Oh, not on a calculator. Square root of 19 times the square root of 19. If we do this like number 12,
we'll say, well, 19 times 19, that's where a calculator comes in handy. It's got to be under 400 because 20 times 20 is 400. That's the square root of 361. Is 361 a perfect square? Yes, it is.
It is? Oh, because 19 times 19.
So take the square root of 361.
The square root of 361 is 19.
That symbol is asking you, what times itself will give you 361? I think we already know. What times itself is going to give you 361? Excuse me.
Okay. So, oh no, Tim, turn off the microphone. He's getting a call from T.D. Anderson. Okay. So, was there something special about square root of 19? Let me see. The answer here was just 19. Let me check it. And instead of going on, let's do another problem. Let's say similar question. Oh, y'all want to hazard a guess on this one?
So it'd just be 31?
Just a 31. We're going to state a rule that we're going to be using all semester. That's the thing that makes math hard to a lot of people, the way it builds. Okay? It's like a foreign language. You cannot take, Italian 2 unless you've taken Italian 1, unless you already know some Italian, okay? You can't just jump in. Here's a rule. Square root of something times itself. If we have the same numbers under those square roots, when we multiply something by itself, what are we going to get?
The number.
There it is. As long as it's the same number under both square roots, square root of 19 times the square root of 19 is just 19. Now there's another way to write what I've just written right here, and we'll be seeing that on Wednesday. Instead of writing square root times itself, it could be written like this.
a square root squared. Okay, so square root of a times itself is just whatever's under the square root. When you write it like this, a square root squared, that leads you to decide that square root symbols and squares cancel each other out. That's going to be important on Wednesday, okay? But right now, let's just make sure we have the hang of this on number 13. Instead of saying next question, I'm going to do one more. Okay. Now this one, hopefully, the numbers are so small, you can easily see why we have that rule. The square root of 3 times the square root of 3, according to my red rule, should just be 3. But if you actually multiply 3 times 3, what are you getting? 9, and the square root of 9 is 3. So it should be obvious. Sometimes we tell y'all rules, and you may not understand why, but you should certainly understand why this red rule is true. The square root of 3 times the square root of 3, if we showed the steps, it would be the square root of 9, which is 3. So this little rule here just helps us skip that step. And you might think, well, that's not, a hard step. But if the numbers are big, it's I didn't want to have to multiply, what was it, 31 times 31 a moment ago? Mm-hmm. Okay? So that rule is going to be important for the next class, okay, on Wednesday. Does that red rule apply on number 14? No. Okay, we don't have the same thing under both square roots. So let me see. Number 14, let me write it down. The square root of 7 times the square root of 35. Square root of 7 times the square root of 35. Probably want a calculator to use on this. There. This is always good right here. I'm starting a problem so low on the page. That means it's going to be a short problem. Now, there'll be some times later on in the semester where we're right up here on the page and I'll be like, I better move on to a new page. And that's my pep talk to y'all. Okay, and if you get what I'm saying, then I'm just sort of joking, but it is true. I was looking to see, is there enough room on this page to do the problem? So, talk me through. What am I going to do here?
You multiply 7 and 35.
Start off by multiplying 7 times 35. 7 times 35. That's 245. And now we got to look through our perfect squares and try to figure out. Now, 245 is not a perfect square. Mm-hmm. So, gosh, where do we start it? You want to start at 225? Or if you want to go further along, 144 would certainly not divide evenly into 245. I think I'm going to start with 121 with my calculator. Let me clear this calculator, and you might find it faster than me. 245 divided by 121. Am I going to get a decimal number? If so, then it ain't going to work. Okay, so I'll move on down. 245 divided by 100. Nope. 245 divided by 81. 245 divided by, I'm going through these perfect squares there. 64, does 64 do it? No. 49? Yeah. 49 times 5. I'm hoping by showing this you see my thoughts. Okay, so that's how he's deciding on 49 and 5. Sometimes stuff I can do in my head, I don't want to do in my head because y'all can't see inside my head.
That's why I'm using the calculator there. So 245 is 49 times 5. So let's see. I'm going to think of this as the square root of 49 times the square root of 5.
And then it equals 7 to the square root of 5.
We had 7, square root of 5. Sometimes students say, oh, I don't need to, or do I have to show all this writing that you're doing? Your goal is different from my goal. Your goal is to get the correct answer as quickly as possible without cheating, okay? My goal is to show you my thought process, okay? So do you have to write out everything? No. But you get it as fast as you can. And what did I say that answer was? A 7 square root of 5. Mhm. Okay. Any questions there? Mhm. Okay, so what we just finished doing for those last few problems, 12, 13, and 14, we were multiplying square roots. Starting with 15, we're going to be adding and subtracting square roots. In order to add or subtract square roots, you've got to have the same thing under the square root symbols. Notice how there's a square root of 5 here and a square root of 5 here. To add or to subtract square roots, you've got to have the same radicand. Okay? So let me move over here. I'm going to write a little bit before we do that. And you can maybe you can logic your way through and get the answer before I even write anything. But here it is. You must have like terms, let's say like radical terms. The radical is that square root symbol in order to add or subtract square roots. Now, what do I mean by like terms?
Like the square root has to be the same.
Like terms have the same number under the square root. You can't add a square root of 2 and a square root of 3. Like terms have the same radicands. Again, using the fancy word. And by radicand, I mean numbers under the square root. Okay. So now, looking back over here, here's how we do problem number 15. Square root of 5, no, 4 square root of 5, number 15. 4 square root of 5 plus 5 square root of 5. 4 square root of 5 plus 5 square root of 5.
Would be 9 square root of 5.
Exactly. Y'all hear what she did? She just added the 4 and the 5. The stuff under the square root. Do not add the numbers outside the square roots. Do not add the numbers under the square root. 4 square root of 5 plus 5 square root of 5 is like 4 dogs plus 5 dogs is 9 dogs. 4 square roots of 5 plus 5 square roots of 5 is 9 square roots of 5. That's the answer. I know I can't reduce square root of 5. There's no perfect square that divides evenly into square root of 5. And 5 is certainly not a perfect square. So we type 9 square root of 5. This is like adding like terms with variables. 4x plus 5x is 9x. And that's all based on the thing like 4 dogs plus 5 dogs is 9 dogs. Okay? What's this next one? Okay. Number 16. 4 square root of y. Okay. Plus 9 square root of y is equal to 4 square root of y plus 9 square root of y.
13 square root of y.
Did y'all hear that? You have the same thing under both square roots, so you just add the numbers in front. 4 plus 9 is 13 square root of y. The numbers in front are called coefficients, so we just add in the coefficients. Okay. And you might be thinking, but wait a minute, what are we going to do if they do have different stuff? We'll show that. We'll get to that in a moment. So 13 square root of y. Here, do we have like radical terms? Are they all, is the same number under every one of the square roots?
Yes.
Yeah, so let me write it down. Number 17. 9 square root of 5 minus 8 square root of 5 plus 9 square root of 5. We can add these together because they all have a square root of 5 as the radicand. So I'll just write down that square root of 5. Oh, when this happens, y'all got to tell me. And they're writing, and y'all can't even see what I'm showing. Okay, we have the square root of 5. All of them are the same, so we have a like radical terms. Now just combine the coefficients. 9 minus 8 is 1, plus 9 is 10. Now see how I got 10 square root of 5 in that one? 10 square root of 5. 10 square root of 5. Is number 18 similar to the one we just did? Say no.
No.
Why is it different?
The records are different.
There's different numbers under the square roots, aren't there? So we don't have the option of can't be simplified or already simplified. So that means there should be an answer here. So let me write it down. Number 18.
You switch it.
Okay, well,
Yeah. Oh, you gotta.
I gotta write it down. There's 6 square root of 32. In a minute, say it, switch it. Minus 7
Square root of 2.
square root of 2. There's not the option, like on those problems where you can click already simplified and stuff. So we're supposed to be clicking in an answer. So that tells us we should be able to get an answer. So the only way we can actually add them together is if we have the same number under both square root symbols. Well, let's see if we can get the same number under both square root symbols. Looking at this one here with the small number, square root of 2, can that be simplified at all?
No.
No. But what about the square root of 32? So that's what I'm doing here. I'm going to try to simplify the square root of 32. Watch the colors. I have a black 6. I've carried it down. Now we're going to simplify the square root of 32 the same way we did problems 3, 4, 5. I'm looking to see, have we already done the square root of 32?
No.
No. Okay. So let's look at our list of perfect squares. Okay, 32 is not a perfect square. What's the biggest number? You might say 4, but no,
It's
there's a
16.
bigger one, 16. You've got to use the biggest perfect square. So I'm going to rewrite that 32 as square root of 16 times square root of 2. Notice what I was talking about earlier about the way this stuff builds. We're doing what we were doing on problems 3 through 11. Okay? That's another reason why in this course you can't just jump around in the assignments. Now let's simplify this. I'm carrying down the black 6. It's right there, and the operation here is times. What red number am I going to write now? A 4. The square root of 16 is 4. Now, what number's under the square root symbol?
2.
A 2. So, the 6 times 4, I can go ahead and write that as what? 6 times 4?
24.
Okay, so here's the problem we have now. 24 square root of 2 minus 7 square root of 2. Is this problem similar to 15, 16, and 17?
Yes.
Yes, we have the same thing under both square roots. This is the most basic problem-solving strategy in the world. If you're confronted with something new, try to make it look like something you already know how to do. We know how to do it if we have square roots, the same number, under both square root symbols. So what's 24 square root of 2 minus 7 square root of 2? What am I about to write here?
17.
17 square root of 2. (17 square root of 2). 17 square root of 2. Okay. Okay. The last two problems, here's the last two, they gotta be the hardest two, okay? We've added, subtracted, multiplied, and divided, we've added, subtracted, and multiplied square roots. Okay, let's see, we started multiplying with 12, 13, 14, that was multiplication. And then we started adding and subtracting. Right now, we're going to divide square roots. Okay? Division of square roots has a special name. Division of square roots has a special name. Let's start off with an example. Here's one that I believe y'all could get the answer to it now just by knowing what a square root is. Suppose we had the square root of 25 over 36. What's the square root of this fraction? 5 over 6. The square root of 25 over 36 is just 5 over 6. If both of the numbers are perfect squares, then it's quite easily done.
You just take the square root of the top number over the square root of the bottom number.
Okay? The natural question to ask is, how do we do this if, show that problem again that we're about to do? Can we do that there on number 19? Do we know the square root of 17 or the square root of 3? No. Well, the instructions say rationalize the denominator. That's another way of talking about division.
let me go ahead and write a sentence. To rationalize a denominator means to rewrite the expression so that there is no square root in the denominator. Like on this example I made up, our final answer shouldn't have a square root in the bottom, and it doesn't. It's just a 6. Well, let me write that problem down. What was it?
Square root of 17/3.
I'll show y'all now. Yeah, this is number 19. The square root of 17/3. I probably should have, when I did this problem, actually showed this step. I'm thinking of it as square root of 25 over the square root of 36. That's where I got the 5 over, well, I didn't get it, y'all got it. Y'all told it to me. Square root of 36. But let's go ahead. If I wrote this as square root of 17 times, over the square root of 3.
Well, we can't reduce the square root of 3. 3 is a prime number, but you can't leave that square root in the denominator.
So what we're going to do is multiply this fraction above and below by the same number. A number over itself is a 1. And what I'm thinking that I want to do is, instead of a square root of 3, I just want a 3.
Go back to number 18. Number 18. No, number multiplication. No.
Yeah.
Oh, it did.
No, it was up way over here.
Oh, good.
Y'all remember
Oh,
my
the
little
square root of
red
19.
rule?
Oh, yeah.
Where I said a square root times itself gives you what's under the square root? What I'm going to multiply above and below by is that square root in the bottom. And I'll write a sentence in a minute. I'm trying to rewrite this fraction so that I don't have a square root in the bottom.
Do y'all agree? The square root of 3 times the square root of 3 now just gives you a 3.
Yeah.
Okay? But the number on top is going to get bigger. And you'll still have a square root there, but that's fine. It's fine to have a square root in top. You just can't have a square root in the bottom of a fraction.
30 plus 21, is this going to be a 51? What's
Yes.
17 times 3? 51?
Yes, it's 51.
Now, I wonder if the square root of 51 can be simplified. It's not a perfect square.
It's not a perfect square.
Will
Do any of those numbers divide evenly? I don't think so. I think you're right. The people shaking their head, no. You could try something like 51 divided by, well, it wouldn't be an even number. 51 divided by, say, 9. Nah. You can look at those perfect squares and test it yourself, but none of these are going to divide evenly into 51. So
we leave it as square root of 51 over 3. And you might say, well, wait, I like this one better. No, mathematically you don't. You don't want a fraction under a square root, and you don't want a square root in the bottom. So what I just said was, to rationalize a denominator, and that's what the instructions say. Rationalize the denominator. Multiply above and below by, what did I multiply above and below by? The square root in the denominator. Multiply above and below by the square root in the denominator. Denominator down, that's the bottom. Remember, you have the numerator and the denominator. To remember what the denominator is, it's down, D, down below the fraction bar.
Now let's do number 20. It's the last one, so it's going to have to be the hardest.
Well, we better type this one.
Oh,
in.
wait. Oh, look closely at how you type in. Square root of 51 over 3.
I see this first thing right here, that first hot button, it looks like a blue box over a blue box. If you look at it, hover, it says fraction. I know it's hard to read that tiny print.
I think most people can spot that as fraction without
Okay,
having to
so
read it.
this thing here beside it, what do you think that is? That's a mixed number. Algebra doesn't lend itself to mixed numbers. I've never used that key. Anytime during any math course with my math lab. And when you use the fraction, and now I need a square root of 51. So I go square root 51. Then I click down on the bottom. What do I have on the bottom?
3.
3. I check my answer.
You're always going to need a technical typist, Tim.
That's right. When we were young, that was a good career.
Yeah,
Technical
our
typist.
first real job was at Baylor University, and I'll tell you, they had a technical typist there.
Oh,
She
God,
made good money, and she could type all of this stuff on an old-fashioned typewriter. And, you know, we were like, wow, you know, she was treated with such respect. Well,
And she deserved
and
it.
she deserved it, but her job became obsolete. But I remember my boss at the time saying, we're always going to need a technical typist. He was wrong. Okay, so number 20. Let's write it down, and hopefully it's not really as bad as it looks. 14 square root of 3 divided by 3 square root of 2. What do those instructions say?
Just rationalize the denominator. Simplify your answer, including any radicals. Use integers or fractions for any numbers in the expression. They're saying don't type a decimal approximation. If you punch that into your calculator, you'd probably get a decimal approximation. They'll count it wrong.
Sometimes people wonder, what is all these sentences they're writing? Well, to rationalize the denominator, multiply above and below by the square root in the denominator.
What are we going to multiply above and below by here?
Square root of 2.
That's
Yes.
right.
Do I need to multiply by that 3 that's in the denominator?
If you do, you're just going to have messier numbers to reduce.
I didn't say multiply by everything in the denominator. I said the square root. So all you're multiplying by is square root of 2 above and below. Our goal should be to have a fraction with no square root in the bottom. Well, I guess I'll do the first,
The top.
the top. 14, there's nothing up here to multiply with the 14. On top, what numbers am I going to multiply together?
3
The 3 and 2. So we have 14 square root of 6 on top. Now, the bottom is where it gets a little tricky. Watch out.
You have
We have
3.
3. Now, what's square root of 2 times the square root of 2?
2.
Just a 2. Did y'all hear that? That little red rule. Square root of 2 times square root
I
of
was
2.
writing then.
is
I don't
2.
remember writing that, but you took over. That's right. Okay.
Oh, I did?
Y'all did a lot.
Oh, yeah. So I've done a lot.
Yeah. While I was gone.
Okay, do y'all see where I got that green 2?
Yeah.
It's this right here. And where did I get the 6? Well, that idea of square root times itself, that's important. It'll follow us all the way through the semester. So on the top, I have 14 square root of 6. What number do I have on the bottom?
6.
Just a 6. But we're not going to type that in. I just noticed something.
We have a 14 over 6. Ignore that radical for a moment. The fraction 14/6. There's a common factor there that you can cancel.
2.
2, you
So
can
it would
cancel
be
a 2
a-
above and below.
So canceling a 2, that would be a 7 and a 3. So the answer you're going to type in is 7 square root of 6 all over 3. Any questions on our logic there?
So I know that your first day of the semester, every teacher's telling you stuff, read this, do that, and stuff.
I'm going to let them tell me. What do y'all think? I have to type that fraction. What do you think I'm going to click first? That fraction bar. Once again, equation editors like this, what we're using right here, it
used to be science fiction.
Yeah. So I type a 7, and then what do I need?
Square root.
The square root.
If I could have
put a
seen
6.
myself, I'd be thinking, oh my gosh, I must be working for the federal government. I'm training CIA, operatives or stuff on how to do this. Oh wow. I would really be impressed with myself if I could see myself 35 years ago.
Well, I mean, they used to call like the mathematicians computers,
Yeah.
like NASA and stuff like that.
Yeah, the federal government is the largest employer of mathematicians in the world. The U.S. federal government, in particular the CIA. You'd be surprised how many. I guess you wouldn't be after watching all the Jack Ryan TV shows. Those people all have their math degrees. Those analysts.
Close it up now, Tim.
Okay,
wait, notice you have 100. How do I know you have 100?
Right there. And in a little bit, that 100 will transfer over to Canvas, to your Canvas gradebook, okay? It is set up to sync automatically. Well, it takes a while, but eventually
Sometimes it's like this.
Sometimes, yeah.
And then other times, I'll have students emailing me, my grade's not showing in Canvas. Well, okay, give it some time.
Yes. If it doesn't, then you need to tell us, and we'll do a manual sync. There's a way that teachers can manually sync to Canvas.
Oh, wow.
Yeah.
So we've done the first one. Now that we've done the first, well, wait, how many of these different lessons? Oh, this is a new era that started last semester.
This new era started last semester. I'm not sure.
I'm being timed out.
Yeah.
Okay, now we can click on number 2. Notice there's not a green flag.
Now you can move on to assignment number 2, complex numbers. And if you do...
We're not moving on. We'll do that on Wednesday.
We're doing that on Wednesday. I said you can, okay? And you'll notice there's a couple of lecture videos. I guess we should have looked back a moment ago. Not a moment ago, an hour ago, we were starting this and I was clicking on those videos. Let's see.
It's a hoot to look back at them now. Okay, we've just done it. Oh, wait, Tim, are we ready to stop?
Oh, I better stop recording, not filming.